Okay, today we're taking a look at section 4.3 in our calculus. If we open up here into section 4.3, 4.3 talks about graphing and with our graphing functions. So one of the things to notice in here is we have this big 9-step layout that we'll be using for our graphing purposes. So if I can adjust here so we can kind of run through this a little bit better. Number one talks about identifying the domain or interval of interest. Basically, where should we be graphing it, where can we graph it, and overall kind of what's going on with the functions. We'll exploit some symmetry in here. Okay, so we'll take advantage of the symmetry if possible. So for example, is the function even? Once again, f of negative x equals f of x. Is it an odd function? F of negative x equals negative f of x, or is it neither of this? Once again, if it's even, we talk about that y-axis symmetry. If it's odd, we talk about that origin symmetry that could be going about it. Then we'll start talking about applying our first and second derivatives. Okay, so once again, on step 3 right here, they're needed to determine extreme values, concavity, inflection points, intervals of increasing, decreasing, within here. From there, we'll find our critical points. So we'll find when f prime of x equals 0, or when is it undefined. And then we'll look at the second order derivative. When is it 0, when is it undefined. Once again, because for step 5, when our first order derivative equals 0, that'll tell us on the intervals at which we're increasing or decreasing. And then on step 5, when our second order derivative equals 0, that kind of tells us when our intervals have concavity upward, concavity downward then. And then remember those inflection points for exercise 6, once again, deal with when that first derivative and second derivative equal each other on there. We'll locate any asymptotes and determine any end behavior. Okay, so once again, we'll talk about vertical asymptotes. So when is that original function undefined? We'll also talk about what happens as the limit as x approaches infinity and negative infinity in here to determine any horizontal asymptotes or the end behavior that's going on here. We'll set our original function equal to 0 to find any x-intercepts. Y-intercepts, even though we can do that in here, we don't do much with that as asked to. And then we're going to choose an appropriate graphing window and plot the graph, which basically means on our paper when we're graphing this by hand, because that's some of the focuses that if we can do this by hand, we should be able to understand fully what is going on. So this is our complete graphing approach to what's going to be going on and everything we're looking into it. The next thing would be some examples.